how certain desk orientations affect student productivity. Imagine this. You are sitting in class and the teacher calls on you to answer a question. Then you realize for the past 5 minutes that you just have not been paying attention and you have no idea what the class is talking about. This is an experience that everyone has experienced at some point in their life. Yannick Linder discusses how after every 15 to 20 minutes, students' attention span drops to a minimum of 0%. This surprising statistic explains how important it is to try and improve student productivity, since student productivity is an area that all teachers wish to increase within their classrooms, whenever it be a student's grades or their overall participation, as well as since student productivity has a direct relationship to the student's academic understanding as well as their academic level. With this question in mind, my research tries to answer how does desk orientation of a classroom affect student productivity. In order to answer this question, I researched articles that talked about how classroom environments can affect student productivity. One of these articles was Omar Lopez's Classroom Diversification, a Strategic View of the Educational Productivity. This article explains 2 variables that will need to be discussed within my research. The first of which is student orientation, and these are teachers' interactions with students and desk orientations. Both of these are able to influence the amount of productivity within a classroom. So, in order to specifically determine that one of these factors is the only one affecting my student productivity, I must create precautions that are able to eliminate the possibility of other variables affecting the data. Another one was Molly Epsey's Does Space Matter? Classroom Design and Team-Based Learning. This article is relevant because it is a research project that revealed the relationship between desk orientation and student productivity within a college lecture environment. Since college students and high school students are very closely related on a cognitive level, this research heavily influenced my research method in order to truly test which desk orientations can improve student productivity the most. These articles are 2 of the very few articles that I was able to find pertaining to the relationship between desk orientation and student productivity. There were a few gaps within my research. One of them was within my articles, none of them discussed high school classroom environments. Instead, they were more pertaining to college lecture environments or worker environments and how these certain factors affected worker productivity. A second one of my gaps was how there were very few articles discussing the relationship of desk orientations and student productivity. Instead, they were more focused on how temperature, teacher interactions, or even lighting would affect student productivity. The third of these is if it was talking about high school students, it was more about how teachers the teaching methods rather than the actual classroom's environments affected student productivity. With these gaps in mind, I will be researching desk orientations within a high school classroom environment. So why desk orientations? The other articles I researched discussed other factors such as lighting, teacher interactions, and temperature. As well, the only articles pertaining to this relationship were about college students in a college lecture environment. So I decided to research the relationship between desk orientations and student productivity in order to fill this gap within the research community. I hypothesized that a more spread out desk orientation will increase a student's productivity in a high school classroom environment, as well as these spread out desk orientations will tremendously promote student productivity and improve students' overall understanding of the subject. After reviewing several articles and referencing Ms. Epsey's research method, I was able to design my own research method that would be able to identify how certain desk orientations affect student productivity. So how will I control these several factors mentioned earlier? So I plan on keeping the temperature within the classroom at a constant 72 degrees Fahrenheit, which, according to Mark Brackett's article, Classroom Emotional Climate, Teacher Affiliations, and Student Conduct, said that this type of temperature is a neutral temperature that has no effect on student productivity within a classroom environment. Earlier, I discussed how teacher interactions with students could potentially influence student productivity. In order to prevent this, I asked the teacher to interact with students equally during the testing period so that this factor couldn't affect my data. For lighting, I was actually unable to change the lights, so I was forced to use LED fluorescent lights throughout the entire study. So how will I test student productivity? I plan on using a pre-test, post-test design where I will first test the students in a controlled desk orientation. Then I will change the desk orientation, and after a week in this new desk orientation, I will test them again with a variation of the first test. I will repeat this process for each desk orientation. The type of test I will be using is a practice SAT math section with calculator. Each test will have 20 questions assessing a student's base understanding of the math section of the SAT. The test will be graded on a 0 to 100 scale, with 100 being the best score and 0 being the worst. Then I will collect a grade range and a mean score. The grade range will range from 0 to 50, 50 to 60, 70 to 80, 80 to 90, and 90 to 100. In order to see if there is an improvement in student productivity, I will compare the class range to earlier class ranges with other desk orientations. So why am I using the PSAT math section with calculator as my test? I'm using this since the SAT allows a constant test to be used multiple times, since each test is a variation of each other that still tests a student over the same material. I'm specifically using the SAT math section with calculator since the PSAT math class was the only classroom where I was able to conduct my experiment in. So the type of lessons that the teacher used over the testing period was called Share and Serago. Share and Serago is an online course that has printable copies and lesson plan for teachers in order to help prepare for the SAT. The lessons that the teacher took were from the Math with Calculator section that are available on her website. The teacher would hand out these copies and then teach the provided course for 20 minutes. Then the students would take the practice that is provided and do that for the remainder of the 15 minutes. In order to see which desk orientations increase student productivity the most, I chose 3 different desk orientations, all of which excel in one certain area. The first desk orientation is composed of students in rows, and it is called the rows and desk orientation. As you can see, it is where students are in a single file row, spread out from each other, each facing the teacher in the front of the classroom. This type of orientation is supposed to act as a control, since this is how the classroom normally is. In this orientation, students are less likely to be distracted by one another and more focused on the teacher, with individual learning being facilitated as a result. The second desk orientation that I used is a small group pod desk orientation. This is where each students are in groups of 4, each facing each other. This type of orientation allows the students to talk amongst themselves and is supposed to facilitate collaborative learning instead of individual learning like the first orientation. The third and final desk orientation is the horseshoe desk orientation. In this desk orientation, students are aligned in a horseshoe-like shape, with some lined against the back wall facing the front of the desk, while the others are on each side facing each other. This type of orientation encourages discussion between the students and the teacher. This orientation also encourages group learning, however, it allows the teacher to be more involved compared to the second desk orientation. The first class I will be testing will be identified as Class 1. Within Class 1, there are 11 high school sophomores, and they will be taking the test during the first part of 6th period. The second class that I will be testing will be identified as Class 2. Within Class 2, there are 12 high school sophomores, and they will be taking the test during the second part of 6th period. Both of these classes are going to be in each desk orientation over the same amount of time, and will both receive the same variation of the practice SAT test and the same Share and Serago lessons, with the only difference being what is shown up here. After using this research method, I was able to gain these results. All the charts below depict students' grades on the practice SAT math section with the calculator test, with the x-axis showing the student's grade in each range, and the y-axis showing which number of students scored in this range. This graph is for the desk orientation for Class 1. The class average for Class 1 in this desk orientation was a score of 71.6, with most students scoring in the below 70 bin or the 80 to 90 bin. This graph is for the rows and desk orientation for Class 2. The average for Class 2 in this desk orientation was a score of 62.2, with most students scoring in the 60 to 70 bin. This graph is for the small group pause desk orientation Class 1. The class average for class 1 in this desk orientation was 58.6, with most students scoring in the below 50 bin, 50 to 60 bin, and the 60 to 70 bin. This graph is for the small group pods desk orientation for class 2. The class average for class 2 in this desk orientation was 64.2, with most students scoring in the 70 to 80 bin. This graph is for the horseshoe desk orientation for class 1. The class average for class 1 in this desk orientation was a score of 77.7, with most students scoring either in the 70 to 80 bin or the 80 to 90 bin. Finally, this graph is for the horseshoe desk orientation for class 2. The class average for class 2 in this desk orientation was a score of 77.5, with most students scoring in the 80 to 90 bin. The outcome of this data showed that the horseshoe desk orientation worked the best. This data shows how out of all the desk orientations tested, the students in both classes should learn under the horseshoe desk orientation. Within my data, it appeared that neither lighting nor the teacher interaction had much effect on my outcome. This could be because I used LED fluorescent lights throughout the entire study, and I asked the teacher to remain equal to all students. This data also helps fill the gap established within my literature review, since there was minimal data about the relationship between desk orientations and student productivity. However, my data is able to fill this gap by providing data showing the correlation between these two variables within a smaller high school classroom setting. Now, with my data, it can be stated that in a classroom environment, the horseshoe desk orientation works the best out of the 3 desk orientations and increasing a student's productivity within a high school classroom environment. There were a couple of limitations with my research method, the first of which was a small sample size. This is because I was forced to collect in my own school, so I was only able to study 2 classes, one with 11 high school sophomores and the other with 12. This small sample size could skew my data, since it could make it seem that a certain desk orientation is either worse or better than it actually was. This is because with a smaller sample size, outliers have a greater chance to skew my data. The second limitation was how I only used the PSAT math class. This is because I was only able to get permission to test the PSAT math class. The third limitation was how during my data collection there was a power outage, causing my data collection of the horseshoe desk orientation to be delayed by a week. However, I was unable to see any drastic changes in my data because of this power outage. Still, it could have affected my data in some way. The final limitation is how I was unable to change the light fixtures to neutralize that wouldn't affect student productivity. This is a limitation since, as mentioned in my literature review, lighting has the possibility to affect student productivity. However, in my findings, I was unable to see any drastic changes from the lighting. So what are the further research and implications that can come from my data? For future research, I suggest applying this research method to elementary or middle school students. This is since elementary and middle school students have shorter attention spans than high school students. This is because attention span tends to increase as people mature and develop cognitive abilities. This change in age may prove that different desk orientations improve a student's productivity more depending on the student's age. For this particular research, I also suggest including more desk orientations that pertain to younger students. An example being all students together in one big group. Another possible future research method could be to use this method in non-mandatory classes. This is because students may be more interested in non-mandatory classes compared to core classes that the schools force upon the children. This could in turn lead to a desk orientation being more efficient than others, or the desk orientation not affecting student productivity at all. This is since in non-mandatory classes, students choose to take this class, so they may be more interested throughout the entire class instead of the highs and lows like a core class. Therefore, the orientation of desks may not significantly affect their performance in non-mandatory classes. In conclusion, student productivity is an area of education that always needs improvement. Though it doesn't solve the entire problem, specific desk orientations are capable of increasing this productivity, since the horseshoe orientation increased student productivity exponentially compared to the other 2 desk orientations. This study, although it only analyzed high school sophomores, was able to expand upon what was already said in the research conversation by connecting the relationship between desk orientations, and student productivity within a high school classroom environment. It also provided more insight into an under-researched factor of productivity that corporations would be able to use to increase worker productivity. This study opens up avenues for further research as a foundation to determine the overall desk orientation for learning. If other schools were to replicate my research, then students would be able to be more productive in class and would have the opportunity to expand their learning as well. Thank you.
Thanks, Arch. That was great. We now have a few questions for you.
How did your review of the methods used by scholars in the field inform your selection of a research method or process that's aligned with your research question project goal?
So, as stated, Molly Epsey's research method was about the desk orientations and student productivity. However, it was in a college lecture environment. So I basically used that and used parts of it in order to influence my own research method. Just instead of college lecture environments, I used it in a high school classroom environment.
How does your new understanding address a gap in the scholarly conversation?
So as stated in my research, it was able to address how desk orientations and student productivity within a smaller high school classroom environment, instead of, as stated in the research conversation, it was more pertained to a college lecture environment. So I was able to connect that gap between those two.
And lastly, if you could revisit your research process, what would you do differently and why?
So if I were to revisit my research process, I would include the PSAT English class. The reason I wasn't able to do this was because I had a class during that time myself, so I was unable to get enough time to visit both classrooms.